All right, everybody. Welcome to the notes on. Goodness gracious. Welcome to the notes on Chapter 3-3, rate of change and slope. So huge, big concept here that you're going to use the rest of your math careers. Really need you to focus and pay attention today so you know what we're doing. All right. So rate of change is a ratio that describes a change on average, how much one quantity changes with respect to another. And here, the key concept I need you to understand is that when we do rate of change, it's the change in the values of the y-axis divided by the change in the values of the x-axis. Okay, so changes in y divided by changes in x. Okay. So example here is that we have number of computer games and a total cost, and so what we can figure out is that each game costs $39. That's going to seem relatively simple to you guys. We just do the difference between the two, between two of the y's, and it doesn't matter which two. It could be this one and this one. It could be this one and this one. It doesn't matter which two as long as we stay consistent. If we do 234 and 78, we need to do 6 and 2. Okay? So real simple, quick practice problem. Find the rate of change here. So what's the rate of change? So let's pick any two y's. It doesn't matter which. Hopefully somebody said that one because I just feel like doing that one. So we'll do 144 minus 48 divided by, and then I've got to pick the x's that correspond to that. Okay, so 9 and 3. So 144 minus 48 is, hopefully somebody said 96. And 9 minus 3, goodness gracious, handwriting today. And then 9 minus 3 is 6. And then we always want to simplify, always, always, always. And so that's 16. So the rate of change is 16. That's part A. Part B is what's the meaning of the rate of change? Well, if the number of floor tiles and the area of tiled surface is what we're looking at, then in 16 tiles, how many, well, let me ask you. Pause the video for a second. Think. If this is the number of floor tiles and this is the tiled surface, what does this rate of change mean? We had surface over floor tiles. What does this mean? What does this mean? And it's in inches squared. Hopefully you said that it means one tile would give us 16 square inches of surface. That's what it means. All right. So we've seen rate of changes that are constant, and in most real-world changes, the rates aren't constant. So we can have sort of a variable rate of change. And what you'll notice is that on this graph right here, it's steeper than it is obviously right here, and then again it changes steepness again right here. All right. So we could have a different rate of change depending on which area of the graph we looked at in a real-world situation, and then we'd have to explain the meaning of that. So we'd have to kind of think our way through that. Referring to the graph above without calculating, find the 2-year period that has the least rate of change. Which one has the least rate of change? So the smallest change between the years, and hopefully you said between 2004 and 2002, right? So smallest rate of change would be right there. And then calculate to verify your answer. The error, those answers are already up here. The rate of change for that one was 0.5, okay? But you can tell that just by looking at it. Rate of change is change over time. So the one where it was the smallest would be the least steep. All right. Positive range and change, rate of change means an increase over time. Negative just means a decrease. That's important to know. We want to determine whether each function is linear. So that's another thing we can do with slope. Or earlier you guys had asked me, like, how do we know if it's a line given an equation? We talked about that some. You can tell from a table, and the way to tell is if the rate of change is constant. If the rate of change is the same, then it is linear, okay? Rate of change constant, then we have a line. So you do the math each time. The difference between these two divided by the difference of these two, and the difference between these two divided by the difference. And so you see if you get the same thing every time, and if you do, then it is a line. So take a second, pause the video, try 3A and 3B. Tell me if you get those as lines or not. Go ahead and pause the video right now. Go pause. Pause, pause, pause. All right, you've unpaused. Hopefully you got the same thing I did, that 3A was not a line and 3B was. If you didn't, check your answers again, see if you can find your mistake, and if you still need help, make a note of that somewhere, and we'll go over that one in class. 2. We're going to talk about slope. So slope is the slope of a non-vertical line is the ratio of the change in the y-coordinates, which we call the rise, okay, to the change in the x-coordinates, which we call the run. Very easy way to remember this. Slope equals rise over run. Students have no problem remembering that, but sometimes we forget whether to put the y on top or the x's on top. And I'm going to tell you that y's rhymes with rise, so they both go on top. So it's y's over x's, y's rhymes with rhymes. So it's rise over run, okay? And the rise over run is just the vertical change over the horizontal change. So on a situation like this, we can literally look at it. And from this point, the rise is down 5, okay? So from here to here, the change is 5. From here to here, the change is 3. The line is going down from left to right. So I know it's going to be negative, so that slope is negative 5/3. So let's take a look at how we use this. The key concept here, I'm not a big fan of this formula. We've stressed this formula for so long. I'm a bigger believer in this, that if you know how to plot points, and you can give yourself a sketch like this one down here, then just look at the difference, and I literally mean difference like distance on a number line. How far apart are the two numbers, and then just make sure to put the y's on top. And I'll show you what I mean. Okay, I'll show you what I mean. So like for example, down here, we have this line. Is the line going up or down? And the answer to that is yes. So I know right away that the slope is positive, okay, because the line from left to right is going up. Then all I have to do is count the shift. Okay, so vertically, from this point, we're using this point and this point. Vertically, the shift is 5. Horizontally, the shift is 3, so it's 5/3. Okay, even when I have negatives, this one is negative. So, okay, so it's the negative points, but the line is going down, so the slope is negative. And then I just, vertical shift is 7, horizontal shift is 5, 7/5, and it's negative because it's going down. Here we have a horizontal line. And we'll talk about why horizontal lines, there is no vertical shift, so it's 0 over 5, which we simplify to 0. It could be 0 over anything. You don't even need to know. A horizontal line, slope, which is m. We use m for slope. That's because m was Latin for montana, which means mountain or hill, and then steepness is what slope is, so that's why it's m. Anyway, so a horizontal line, the slope is 0. Go ahead and pause the video right here. Try and get some slopes here from, actually, let me do 4A for you. Let me do one more example so we can see what we mean. So we have, I'm just going to sketch this for myself. And the sketch is not going to be good, but it's going to tell me positive or negative, and that's important. So over 3 up 6, say that's there. Then I go over 4 up 8, so that's there. Is that perfect? No, of course not, but it tells me that the line is going up, so I know the slope is positive. Then I just do how far from 6 to 8? And the answer to that is 2. How far from 3 to 4? That's 1. So the slope here is 2. Please don't tell me 2 over 1 is an answer. Okay? The slope here is 2. Go ahead and pause the video. Find the other 5 slopes. Pause the video now, please. All right, you've unpaused. Here are your answers. Ready? 4B, the slope is 0. 4C, the slope is 4. 4D, the slope is 0. 4E, the slope is negative 1/2. Don't tell me 0.5. 4F, the slope is negative 8/5. Improper fractions, please. Okay. One thing to notice, and hopefully some of you did notice, when the y value repeats, that's when it has a slope of 0. That's a good thing to notice if you did. Let's take a look at this page. Undefined slope. Undefined slope. So here we have the y's are -7, and then the difference between the x's is 0. If you put in 7 divided by 0 into your calculator, it's going to tell you some sort of error message because that's not possible. Okay, so anytime you have 0 on the numerator or on the denominator, the answer is undefined. Don't write anything else. Don't tell me 0 with a line through it or NA or any of that. It's undefined. Okay, and hopefully what you'll notice is that, look, when the x's repeat, the slope is always undefined. Okay. I like this little box right here underneath. I think it's a good indicator of important things about slope. When it goes up left to right, it's positive. Down left to right, it's negative. Horizontal, it's 0. And vertical is undefined. Find coordinates given the slope. I like this problem because we have to work backwards a little bit. So I tell you that the slope is 1/3. I tell you that one of the points is 1/4 and the other points is -5/4. So you have to set this up and then solve for the missing number. I'll do 6a and then you do 6b. So here the slope is -5, okay, -5. And that's going to equal the difference between the two y's. So we'll do 6 minus -4, okay, and then the difference between the two x's, -2 minus r, okay. 6 minus -4 is 10. And then we have -2 minus r. Okay, a couple different ways to do this. The way they did it up top here, thank you, is we cross multiplied. Not thank you. Thank somebody else. Someone was in the room. They were listening. So we're going to cross multiply. The 5 is really 5/1. So I'm going to do -5 times -2 minus r equals 1 times 10, which is 10. I'm going to divide both sides by -5 in my efforts to solve. And I'm going to get -2 minus r. We've traveled up here now. -2 minus r equals -2. I'm going to add 2 to both sides, and I get -r equals -r equals 0, so r equals 0. So the missing r value there is 0. I'd like for you to pause the video. Try 6b on your own. Go ahead and pause the video now, see if you can find out what that r value is. All right, you've unpaused, and I'm going to tell you r is 4.75. Now, hopefully some of you said 4 3/4, and maybe some of you even said 19/4. If you didn't get that, try again. If not, if you still don't get it, ask me about that one in class, and I'll be happy to show you. I'd like for you to take a look at these problems right here. Go ahead and pause the video wherever you need to for these. You don't have to do all these. Just try a couple. I would especially try 6 to 11 and 12 and 13. I think those are some of the tougher problems. But try a couple of those. See if you can answer them. I will see you in class next time.